Hello, ladies and gentlemen, welcome and thank you for joining this exclusive webinar on automation and robotics featuring Wilmy. My name is Sadin Piaz. I'm senior engineer at Elektor and I will be moderating this webinar along with our folks at Wilmy. Today, we delve into transformation power of automation. In an era of technological advancements, we will explore the concepts that automation made simple with the focus on wheel means autonomous mobile robots, AMRs for short. We're thrilled to introduce you to WheelMe, a pioneering company at the forefront of transformation everyday objects into autonomous, again, mobile robots with their groundbreaking WheelMe genius technology. There are recognized and acclaimed winning the Fast Over 2022 and Tech Innovator at 2022 awards. WheelMe addresses critical industry challenges, including labor shortage, traditional autonomous solutions, and high cost of entry. Their innovative approach aligns with the principles of Industry 4.0, ensuring companies remain competitive in the ever-evolving landscape of automation. Join us if you're curious about automation and simplifying processes in the industry. And we will also learn about WheelMe's Genius 2 technology, learn about its impressive features, advancements, advantages, and challenges in creating robots into various industry sectors, including manufacturing, healthcare, and logistics. Our esteemed guest speakers for this event are Benjamin, sales manager at WheelMe, Casper, head of mechanics, and Alexander. Hi, guys. How are you doing today?
Very well. Thanks for having us.
Very well. Yeah. Thank you.
Hello, guys. Thank you for having us.
Great. Okay. So before we begin the presentation, I want to remind our valued viewers that this webinar will be later available on Elektor TV, on the Elektor TV YouTube channel. And by the end of this webinar, we will have a Q&A session. So please submit your questions in the Q&A chat box, and we will hopefully answer most of your questions. So without any further ado, let's explore the world of automation and uncover its potential. So I'll let you guys begin. Casper, you take the stage.
Actually, I'll start from here, Sad. Thank you. And thanks for Elektor for inviting us to present for you today. I'm Ben. Like Sad said, I have Casper and Alex here with me to represent WheelMe. If you haven't heard of WheelMe before, we've developed the world's first autonomous wheel. So for a long time, companies rely on moving material within facilities, and lately been turning towards robotics as a solution. And as mentioned, we have been recognized as one of the best inventions of the year by Time's Best Invention and Best Tech Innovator by Gartner in 2022. So despite decades of innovation, we haven't really seen a disruption for Industry 4.0. So there's a couple of buzzwords that I like to point out before I start, and one of them is Industry 4.0. So Industry 4.0 represents kind of the fourth industrial revolution. So it's a widespread integration in digital technologies like IoT, AI, and automation and manufacturing processes. So the other is autonomous guided vehicles, or AGVs, and self-driving robots that move material in places like factories and warehouses. So there's several problems causing the market gap and aiming to solve the Industry 4.0. And it's growing rapidly, and more companies are just can't keep up for reasons like the labor challenge. So there's more than 6 million material handlers that are demanding higher salaries, not showing up for work. Another is inflexibility. So a lot of companies are just, having issues automating, especially for the first time. And really, it's hard to do it for the first time because now they need to learn how to incorporate AMRs into their processes. So, and finally, most solutions are really, really expensive. So upfront investments and ongoing maintenance can create significant barriers. So that's where WheelMe comes in. Okay. By attaching our wheels to your existing objects, we can turn almost anything into autonomous robots. So imagine modern facilities like carts, pallets, trolleys, whatever it may be. We can make them all run in perfect synchronization autonomously. So just to compare to AMRs that are out there today, which are typically really rigid, can cost a fortune, high maintenance, our solutions designed to disrupt the market by being flexible, low integration time, and cost effective. This is our latest production version, the Genius 2. And coincidentally, it's being announced today. So Casper and Alex will get into some of those details shortly. But there's going to be a minimum of 4 wheels. The front main wheel has a camera and LiDAR for safety purposes, and each wheel helps support carry 100 kilos. So a set of 4 will move 400 kilos, and we also have an 8-wheel configuration to move 800 kilos. So it's a simple setup, fast, efficient. We basically use custom-built brackets to fit the desired cart. And our modular design, it's truly unique because we use the mecanum wheel, and that can wear out over time. So from a system that we developed called the click in, click out, it allows you to remove the defective wheel and replace it with a new wheel, and just in a matter of seconds. So as for the charging, we do opportunity charging, and that allows us to strategically place these charging stations throughout the facility, so that if there's a waiting zone or a buffer zone, we can conveniently get a few minutes of charge. And as long as it keeps in that positive charge, the wheels don't ever have to come out of rotation to go charge. Yep. So our concept is robotics as a service. You'll get the hardware, the software, and the service level agreement for a fee. There's also a one-time installation cost that covers training and setup. So it's really is a one-time cost, because the idea is once you start identifying more use case, you say, send us a few more sets, and we ship them to you. And because you are already trained, you're capable of doing all the mounting and setup yourself. So currently the Genius is on the market for 390 euros per month per set. And there's also an option to purchase it for 14,000 euros. That's 14,000. The installation cost varies depending on the complexity and the size of the project as well. So these are some actual use cases that we're working on so far. We've entered markets like the automotive, logistics, healthcare, retail, and other manufacturers pretty much all over the world. And our headquarters is based in Oslo, as well as our production facility. We just opened an office last year in the US, and opened a new office this year in Berlin. So needless to say, it's a very exciting time for us. But before I hand it over to Casper, I have a video to show you some of the use cases that we're working on. Every cart that you see in this video is given to us by one of our customers. Go.
All right, everyone. My name is Casper. I am head of mechanical here at WheelMe, and I will hopefully dig more into the details of the product. I'm going to tell you a little bit about how the product is built up, so the hardware of the product. I will also try to repeat a few of the things that Ben has already gone through, just to make sure that you understand the product that we are actually offering. We do have a very flexible design. It is a design where we use our wheels to basically turn any object that our customers may have into an AMR, so an autonomous mobile robot. We offer a very disruptive pricing. So we both have the ROS, the Robotics as a Service, and also a purchasing model with very low prices compared to our competitors. We have a very simple UI. So our application or the ways of operating the units is very simple, so that anyone in the plant, any operator can actually do and define the missions themselves. The fact that the product is also so simple also allows you to shorten down the integration time. Mounting these wheels onto a rack or a cart or an object that you have doesn't need to take more than a few minutes, half an hour to do, which allows us to very quickly implement this into your production processes. As Ben also mentioned, we offer fully automated opportunity charging, which basically means that instead of worrying about robots going out of power and worrying about whether you have to charge the robots from time to time, we put these charging stations out in the process so that the robot stays on a net positive charge throughout the process. These wheels are also able to acquire a lot of data, which is data that both you as a customer can use to optimize your processes, and also data that we can use to optimize both the navigation of the robots and planning out the processes that we are doing. So that basically also covers the last point, which I will allow Alex to talk a bit more about later, which is the advanced mapping and navigation algorithms that come with the system. Just to repeat that, the payload of the system, we have 100 kilograms, which is equivalent to 220 pounds per wheel. And we offer these wheels in sets of 4 and 8, which allow you to have payloads at 400 kilos and 800 kilos in total. As Ben also mentioned, we just released our Genius Model 2, which is good news. This is a system that has actually been certified with industrial safety. So we can now proudly say that we are compliant with SEAL 2 or performance level D and compliant with IEC 61508 standards. Moving on, I want to show you a bit how the product is built up on the mechanical side. If we start at the top, we see a 2D LiDAR. On the Genius 2, we actually have 4 of these, which allow us to get a 360-degree field of view around the robot for safety purposes. And by having 4 of them, we also offer a redundancy on this safety feature. In addition to the 2D LiDAR, we also have a 3D camera that we use both for obstacle detection and avoidance and also for navigation of the robot. In addition to that, we have a processing unit, which allows us to do many of the processing tasks on board in the robots so that we are not directly in or dependent on connectivity at all times if that happens to go down. With Genius 2, we have also released a new additional localization module. This is a localization module that allows us to get even more robust localization in any environment that we operate in. So that is good news. And then over to more mechanical details. At the bottom, you see the drive system that we use for our wheels. It's called the Mecanum wheel for the ones who are not familiar with it. It is a drive technology that allows you to obtain omnidirectional maneuverability, which basically means that you can move in any angle or rotate on the spot by using 4 of these wheels. So basically with our 4 wheel sets. Over that, we have the suspension system. This is probably what we can call the mechanical integrity of the product. It's a casted aluminum part that holds the Mecanum wheel and ensures the appropriate rigidity or stiffness for the products. The core assembly that you can see above that is an enclosure part that is injection molded plastics. Same with the battery packs that we supply in both 10 amp hours and 20 amp hour configurations. Above that, you can see the different sensor modules that we use for our wheels. We have 3 different configurations, and that is basically 3 different configurations so that we can put the wheels on each of the corners of any object that you may want to add the wheels onto. On the top, the yellow controller on the top is the hand controller. As many probably are used to, this has an emergency stop button, the red little button on top. But this controller also offers the opportunity to actually manually control the robot with a joystick, just like a PlayStation controller or any other controller that you might be familiar with from before. On this controller, there is also a button that can be used by operators to send the robot to the next goal, but I will allow Alex to talk a bit more about that later. As Ben briefly mentioned earlier, we use adapters to fix our wheels onto customer carts. That is because usually the caster wheels that are used on the racks or objects have many different hole patterns. And we then need to add a little part to make sure that we can go from the existing hole pattern on the object and over to the hole pattern that we have on our wheels. Depending on the project, we do both low and high volume production of these. If we only need it for a few sets, we might do either FDM printing or SLS 3D printing. Whereas in other cases where we need a higher volume, we can look towards creating injection molding tools for them. We also do adapters in sheet metal and other materials as well. Here is a little picture of the charging station that will also be released now with Genius 2. It is mounted on the ground, so it's surface mounted charging. And that also gives us a lot of flexibility so that we can mount these onto the different positions throughout the process and make sure that the robot always stays on a net positive charge. In addition to that, I just wanted to mention that, we want to offer these wheels at a high scale. So we have always had a great focus on scalability of the products. That is why we have created it very module-focused, module-based. We have also aimed towards getting automated assemblies. Right now, we have 3 different automated assembly cells in our production facilities. We use mass production methods to create our parts. The top left picture shows a picture of our casting tool for one of the aluminum parts for the suspension system. Many of these are actually supplied from local suppliers in the Oslo area or in Norway where we have our production facilities. The wheels are also super easy to install. As I mentioned earlier, these can be unpacked and mounted in as little as 30 minutes. They're also easy to maintain, as Ben mentioned as well. With the modular design, the click-in, click-out mechanic wheel, the different sensor modules, everything is very easy to mount and dismount if necessary. So if something is broken, it doesn't lead to a lot of downtime for any of our customers, and that is one of our main goals as well, to ensure that we have uptime all the time. And then I will hand it over to our head of robotics, Mr. Alexander, sitting right next to me.
Yeah, thank you very much, Casper. All right, my name is Alex. I'm head of robotics here at Wilmy. I deal mainly then with the software and firmware on the robots themselves. So basically, how the robots know where they are, where they're going, and how we communicate this to our users and operators as simply as possible. So I want to start by giving you a brief overview of the whole system and the architecture in general. If we start from the bottom with the robots themselves, as mentioned, they're basically rolling sensors. We have new on the Genius 2, we have a laser scanner on every single robot, which means that we have full 360-degree high-resolution overview of plane around the robot itself. And this provides us, and as well, that's fully redundant. So even if 1 or 2 LiDARs fail, we will still have full safety systems. And on this level, we're running our own proprietary firmware to be able to comply with the said safety integrity standards that we want to conform to. And we also have a 3D camera, a localization wide-angle view camera that are both used to detect the environment around the robot. So what you do when you arrive on site the first time is that you drive one set of robots around and get familiar, if you want, with the environment that is there. We then use the camera itself to map out the entire area to get an overview of what type of features the robot can look for while it's navigating around, to know where it is itself. And while it's navigating, and it can use its 3D camera to detect obstacles that it might encounter on its path that are not detected by the laser scanners. Once this is in place, we can create missions. We can distribute this map to other robots within the same facility, and they can update that as they're driving to ensure a constant up-to-date map, so that they will all be able to localize within this environment. And with all of this sensor data, it's of course beneficial to the client to be able to gather some insights from that. And there we have a data enrichment and the processing unit that is able to take in a lot of the telemetry that we can gather from the wheels and increase efficiency in the plants that we operate in, as well as do predictive maintenance or help with servicing our own robots remotely. And we can do all of this over the air if desired. So we can provide a cloud environment that we can host the infrastructure on, or we can do this on premise for the clients that want to control all of their network security internally on their own facilities. So if we move on, I'll bring you through how we actually deploy these robots. What the main thing the user will operate with is map, a 2D overview of the environment that they mapped out with the initial survey of the robots around these plants. So we create this map, and through that you can create all of the missions that you want the robots to run. So you can create and connect various positions together with conditions that the robot will then be able to perform autonomously on their own. But you can also control the robots on an individual level. So you'll be able to send the robots to next goals and control them using remote joystick or etc. I'll come back to this in a bit. So I'll bring you now into kind of some actual use cases where our robots might be useful. And we normally operate around production facilities. We have some logistic facilities as well, but our niche and flexibility really comes to shine in existing workflows where you simply just want to automate a workflow that is already in place but done manually. So if you look at a couple of use cases here, we normally want to fulfill an assembly line to provide that with all of the parts that's needed. This can come either from the supermarket area, where we just distribute goods from bulk provision of goods to the assembly line itself, or where we create sub-assemblies that continuously have to be refreshed at the assembly line. So if we dive into this first use case, there's a demand for sending material from assembly line to the assembly line itself. Here the robots are able to be provisioned at the sub-assembly line, and whenever they have been fully kitted out, an operator can press a button and it would autonomously navigate to the assembly line to whichever position is available. So we always keep the assembly line fulfilled. There's always at least one cart at the assembly line, and the sub-assembly line should just push out carts whenever they're ready. This really adds up over time. We see a lot of our clients have problems manning their lines, and we have up to 23% no-show rates, as has been mentioned. And doing material handling is a very easy to automate and low value adding part of most assembly procedures. So here we are able to effectively increase the productivity of the plant in total. Another very typical use case we run into is bringing parts from a supermarket to an assembly line. Here, the production line might be slower or faster depending on whatever you're doing. But we have, as you can see, a supermarket area to the top left in our map here. Whenever there's an operator available, they can pick up and fill whatever goods are required for the given assembly or sequence or kit out full parts. Send it to the assembly line, and we can have a cart waiting arbitrarily close to the assembly line. And whenever it's waiting or whenever it's ready there, the cart will autonomously navigate to the assembly line on a signal from either from our user's automated system already or from our cart being pressed. So I'll give you some insight onto how the users actually set up these missions. So what we normally see is we have those missions that I just showed you are kind of an idealized version. Normally we have multiple positions being serviced at once. So in this example, this is one of our clients. We have multiple picking positions on the left here, and any of these robots can go to and fulfill the unloading area to the right. And we also have a charging station for robots that are just waiting to be picked. And here you can see how you can distribute robots to however many positions you need, and also bring them together to always keep a key part of your mission fulfilled. And you can set up the conditions however you want. If you want the highest priority carts, if you want the highest priority conditions, if you want only robots with a large amount of battery, whatever you need to fulfill your positions. So if you move on a bit, this is an actual use case at one of our clients. We go first in on site, we analyze the mission itself and see what they actually need from us. So here you can see the bottom left is the production site that they want fulfilled. And the top right is where they actually pick parts and put our sub-assemblies. They need to transport a sub-assembly from the top middle, I guess, down to the bottom left. Sorry. And we also have here a waiting position that just is able to create a buffer for both sides of this mission. So in case they're still at the sub-assembly, they have a buffer at the assembly line, and the same at the sub-assembly, and a dedicated charging area up in the top middle there. So with our system, it's very flexible in whatever needs you have. So this is kind of the autonomous process. You just set it up and you press buttons and the robot simply navigate around. But you'll also be able to control the robots remotely. So here you have the remote control. You can save positions that you want to use later. You can control it through a joystick. You can elevate it up or down. And as mentioned, with omnidirectional wheels, it's quite simple. You can drive it like you normally would with an RC car, or you can drive it in an omnidirectional mode, so it'll drive sideways or backwards or diagonally or whatever you need. You can also, this is how you normally interact with the robots. You can send them to a goal. Normally, you can just press a button and it will go to the next goal in the mission. You can press that through the user interface, or you can press that button on the joystick itself. So the joystick will always be mounted to the robots, and that's what your operators are normally going to be using. It's just pressing a button and sending the robot wherever it needs to go. So, of course, with all of these robots, you might experience fluctuations in your production frequency, or maybe you have to switch robots to another production line to maintain that, and that's really easy to do in our system as well. These robots are meant to be interchangeable and very flexible, so you can specify whatever mission you want to run the robots on, and simply deactivate them from your mission and activate them into another mission. And once you do that, you might want the robot to go to a specific part of the production line or specific picking assembly. And it's very simple then to send the robot directly to whatever position you've created in advance to use the robot for. So I think that was a lot of information all at once. So we'll open the floor up for some questions. So please feel free to shoot. I saw that there were some ticking in already. So I don't know if perhaps our moderator from Elektor wants to pick out some questions, or if we should just jump straight into them.
Sure, I can take it over. They're very interesting questions, so I'm going to just pick from one. Okay, so we have a question. What about the firmware and the application software? Is it open source or customized?
Right. So we have most of our software is customized. We base some of our software on open source frameworks, such as the robot operating system, and some packages from there. But all of our firmware is 100% proprietary and is what we actually use to be able to certify our product to the ISO standard 61508 to safety integrity level 2 and performance level D.
Okay. What's the challenge you're seeing in the 3D sensor navigation? Reflection, false data, heat?
Yeah.
What about operation outdoor?
That's a really good question. It's something we've actually worked with very recently to improve drastically. With 3D obstacle detection, it's always a challenge dealing with, particularly with ghost obstacles, false positives or false negatives in that case. If you go too far, reflection is a big challenge. So what we've done is we've switched out the sensor to add another infrared filter that helps a lot with direct lights. We don't see too many heat issues, but with that, we've been able to drastically reduce our false positives, which means we are much better at detecting true obstacles. The reflections, although they provide a challenge, have actually been able to we've been able to mitigate them through a very good filtering mechanism through our combination of wheel odometry and visual STEM. And we use actually a third-party supplier to help us with aiding in that respect.
Great. I have a question from my side. So with 3D imaging and image processing, what do you process? Do you monitor the roof for the navigation of the robot, or do you monitor the floor or the baseline? Or at what level are you recording?
So obviously our robots are very close to the ground. So we're a bit limited in our field of view. So if you can see our product, it's the camera is mounted facing upwards. So we actually have two methods of doing localization. With our new Genius 2, we're using this super wide angle camera that gives us basically, I think it's 176 degrees field of view, which is able to record basically everything. But with the 3D camera, it's mainly recording the roof. So we use a lot of visual features in the roof to be able to navigate with afterwards. Yeah, I think that answered the question.
Yeah. All right. Another question. Is there any overweight sensor on each wheel-me? Further, any indication if it's uneven weight or balancing on a set?
Yeah. So currently, we do not have an overweight sensor in the wheels. We do have some ways where we are trying to kind of monitoring it, but we don't have a very dedicated sensor for this as of now. However, we do have a set of requirements that we also supply to our customers that they need to fulfill. So their carts need to fulfill these requirements in order for us to be able to mount our wheels onto them, and that is basically related to the physical restrictions of the Mecanum technology as well. Yeah.
Okay. And are all the wheels in the set, they're 8, right? So are they all-wheel drive, or some of the drive robots and the other ones are steering, or how does that work?
So all of the wheels drive. All of the wheels have an integrated BLDC motor, and they're kind of like a standalone system themselves. However, the mechanical technology requires you to have opposite-oriented rollers. So in a set of 4, we would have 2 rollers that are angled 45 degrees one way, so say clockwise. And then in the 2 other wheels, we would have the rollers oriented the other way, so counterclockwise.
Great. I'm a mechatronics engineer, so I have these questions for you guys because I've worked with robots before.
I really love these questions.
Yeah.
I don't know if it came across clearly enough, but we mount the robots both in sets of 4 and sets of 8. So so as mentioned, they have 100 kgs of payload per wheel. So in a set of 4, you'll have 400 kgs of payload, but we're also able to accommodate up to 800 kgs by mounting an additional set of wheels to our robots.
Cool. All right. What would be the minimum environmental conditions to able to install these robots, for example, in a supermarket?
So I am not sure if this question is directed towards the precision of the sensors or the environment itself. I mean, for basic operation, we currently only offer a solution for indoor operations with standard temperatures from 5 to 40 degrees ambient temperature for operation. However, if this is more directed towards the precision, is it down to 50 millimeters? That is the
15 centimeters.
15 centimeters. That is the accuracy, or the accuracy that we can guarantee with the sensors that we have on the system.
Yeah.
Yeah. Feel free to elaborate more on the question if that did not answer all of the questions that you may have related to the environmental conditions.
Okay, we have a question from Christian. Do you have an API to send missions to the robots from MES or MES, etc.?
Right. So right now we have a pretty rudimentary API that's able to communicate with simple PLC commands by sending robots to and from the position they're currently occupying. We're currently working on a VDA 5050 compliant API that we're planning to release in the not too distant future. So currently we mainly integrate with hardware systems that the clients have integrated already.
A question about battery life. How do they last? How long does the battery last at a full speed? Or
yes. So how fast can they go to begin with? We've currently set it to 0.8 meters per second for the autonomous mode. This is not the full performance of the motor that we have, but it's currently what we have set as a limit due to safety. It is a bit lower for manual operations, basically because you're operating it manually and you're standing closer to the robot. How long does the battery last at full speed? It's always a hard question to answer because it simply depends on the payload that you have on it as well. But I do like to emphasize that what we do is opportunity charging, and we always aim to maintain a net positive charge in the cycle that we put up, so that you do not have to worry about how long the battery lasts.
Great. And another question. Environmental rating in terms of IPX. I think it's purposed for indoor use only, correct?
Yeah, that is correct. So currently we have an IP rating of IP20 on the product, and it's only meant for indoor use. So basically no water ingress into the system.
How immune to electrically noisy environments?
Yeah. Yeah, I can try to answer this. As in many facilities that are struggling with maybe issues related to ESD, so electrostatic discharge, we have naturally also encountered these challenges. However, we have solutions for this. We have in the new Genius 2, we've added extensive ESD protection to all our electronics. We also have the possibility to mount an ESD tail, basically a discharge chain to our wheels, if that becomes necessary, as some environments might be more electrically noisy than others.
Mm-hmm. We also do pretty extensive EMC testing on our product on how much it emits and how much it is able to tolerate, and we haven't really experienced any issues with EMC on our product. The main issue will be if you have a very electrically noisy environment where network is impossible to achieve, then you'll have quite limited performance, as the robots won't be able to communicate with each other or with the fleet management system.
Yeah, speaking of noisy environments, do you use Wi-Fi 2.4 gigahertz, or what do you use for connecting between the robots, like communication protocol?
Yeah, we mainly focus on Wi-Fi. We have done some pilots using 5G, but our current product is using Wi-Fi 2.4. Yeah.
Amazing.
We just real quick, we currently partner with Telefonica, and we're actually in Munich a lot. So there's an opportunity that if you're in the area to stop by, see it in action, and we can give you a demonstration.
Okay. So it's probably going to be a full-on LTE solution in a way, or it's going to be still Wi-Fi?
We're looking into both. We won't remove Wi-Fi as an opportunity. Some facilities that we tested out have their own 5G network internally set up. We probably won't go full LTE. We'll focus on 5G or edge computing, but we want to be able to support that for the facilities that are going to the full extent of Industry 4.0 integrations.
Great. Okay, how does WheelMe failsafe sense unexpected obstacles in its path, optical, mechanical, etc.?
Right. So as I mentioned, we now have 4 laser scanners, one on each wheel. That gives us basically a fully redundant 360-degree view around the robot. So if we detect any obstacle, it will always be detected by minimum 2 of the laser scanners. And if any laser scanner detects an obstacle within its path, it's able to activate the emergency stop, or within its safety bounding box, essentially. It's able to activate the emergency stop, and the system will stop as fast as possible. But we're also, of course, able to detect these obstacles using a 3D camera and the laser scanners on further range. And in that case, we'll do our best to just navigate around them if they're outside of this safety bounding box.
Okay. Yeah. Are they designed only for a flat surface, or what is the maximum slope up or down they can climb?
So
probably in degrees, I believe.
Yeah. So currently the system is designed for flat surface operation. We can operate in inclines up to 2 degrees, which is not a lot. However, we also see that feedback from different customers and potential customers is that they would like the system to operate in slopes. So that is feedback that we will also take into account in future iterations of the products. But as of now, the answer is that we operate on flat surface up to 2 degrees of incline.
Battery technology, lithium ion, sealed lead acid, or lithium polymer?
Yeah. So lithium ion cells, these are also certified. I think they're Samsung cells that we're using right now, 21700. So basically very standard battery cells that we're using for the system.
Okay, it's possible to use in clean room conditions.
Currently, we have not been certified to use in clean room conditions. So I believe that we would have to look into the regulations for operations in clean room. But currently, we do not have any use cases where that is relevant. So that is something we would also have to look into once we have a use case that we want to implement in.
Another question we usually get, is it possible to download the webinar? Yes, it will be available on Elektor TV YouTube channel, so you can download or view it online if you like. Okay, let's take another question. Can they move from one pallet to another pallet if I would like to unload a truck?
Yeah. So we have use cases where we mount our wheels onto frames or basically carts that they use to transport studs or pallets, and they load these with forklifts. We also have some applications where we have designed a frame ourselves for the customer, so that they can also load that with their pallets themselves.
Can the laser scanners at the wheels be used for intruder detection during off time?
No, unfortunately, that's it's not a feature we have implemented yet, but it's a very interesting suggestion.
We'll note that down.
Yeah, we'll put that in the backlog for sure.
Maybe in off time it can become a security system, what's it called, the Scenery mode, or what type of mode Tesla has.
Yeah, exactly. If we find out material handling isn't what
Sentry
we
mode
really, want, then we can go into sentries.
Yeah, I think we already answered this question. I think soil conditions, installation height, etc.
So in installation height, currently the wheel is 135 millimeters tall, with some plus minus due to some suspension. We can always add some spacers on top of that if there are any requirements to ergonomy in the use case.
I think it's the same question again. What sort of services are they designed for?
Yeah, so quickly we operate on anything from vinyl floors to concrete floors, old concretes. If there is a lot of damage on the floor, we usually ask the customer to repair. That is because we would like to reduce the wear and tear of the system. So if there are large cracks or dents into the concrete, we ask them to be repaired. But currently, yes, operate on anything from vinyl to epoxy to concrete.
Question about wheel change. How many seconds? 30 minutes or 30 seconds?
Yeah, okay. I believe that was a bit unclear. I'm sorry for that. So the click-on solution on the mecanum wheel itself has been made to make it easy to repair or maintain the system. So the mecanum wheel, the drive system itself, can be released in seconds. However, what I meant with 30 minutes or less is basically taking 4 wheels out of the box and mounting them onto a cart or a rack or an object, yes, in general. So I hope that clarifies.
Okay. Chat has really been responsive today. Another question: is the system water resistant?
The answer to that is no, as of now.
Okay.
But I mean, it's also important to say that a small puddle or a little splash of water won't hurt the system. It's just that the system has not been designed with with a given IP rating to be water resistant.
What about the lifetime of the system? Do they need maintenance?
Yes, they will need maintenance. It depends on the environment that we operate in. The most fragile part of the system is probably, as some have thought out as well, the mecanum roller itself. It's quite small. However, we see that the cycle or the life cycle of the mecanum roller is quite long as well. The lifetime of the system itself depends on the environmental conditions, but we currently have 4 or 5 year contracts. So that is the lifetime that we have set for the system that we expect it to be, with minor maintenance that can be done either on site or simply by the operators themselves.
With the bot already moving around a warehouse taking pictures, any plan for stock data analysis dimensioning capability in the future?
Yeah, for sure. So we already started this in partial, just figuring out what data is useful and how useful it can be. But we see huge opportunities within, especially manufacturing, where just a small percentage in an efficiency increase results in really large value additions for the customer. So this is, of course, some data that we want to analyze very carefully for our customers. So we're looking into what is the most valuable. But as I mentioned, these are just basically rolling sensors. So the data we gather is really useful, and we gather it from large part of the facility and aggregate it all in one place. So it's easy to see where bottlenecks are and where efficiency gains might be achieved.
Is it possible for a single wheel me to work like a unicycle for some light parts?
The answer to that is no. We currently supply the wheels in configurations of 4. Whether it's theoretically possible, no for 1 wheel, but I think you can do it with 3 wheels with the technology, but with a very different controller to what we're using as of today. Yeah. So 4 wheels is a minimum with the wheel-me system.
Yeah, this is due to the mecanum wheels themselves are not able to be run like a unicycle. Essentially, they depend on each other for traction. So it's a limitation of the mechanical implementation.
Obviously, there will be failures in operation. Can the system function if one driver fails? Can it return base fully loaded? One driver fully loaded with one driver failed, or must be rescued?
So this depends a bit. In general, I would say no. If you have a 4-wheel configuration in particular and one wheel fails, the autonomous system will not allow any more operation. You can still drive it manually, but with reduced control efficiency. So if one wheel fails during an operation, you'll be notified that one wheel needs maintenance, essentially. With an 8-wheel configuration, you have some redundancy, but we currently don't allow the wheels to operate if one wheel fails autonomously, because it's very hard for us to guarantee operation when we don't get the full sensory inputs.
Question from Bob. In a similar related issue, security, is there an area boundary monitor for someone decides to take one or more for walkies? I don't know what that means, but you guys can answer that.
If someone
maybe it means if you try to remove a robot from a plant or from the map, if there is some kind of security monitoring of that.
Okay. Well, we can't really stop anyone from picking the robots up and taking them away, unfortunately. But we, yeah. So if they decide to pick them up and walk them away, that's not easy for us to monitor. But the robots themselves won't drive outside of their given limits. Yeah, we don't have a GPS or anything like that installed on the robots. They depend on being turned on and actually monitoring the environment around them to be able to navigate. So.
Okay, I think that's it for now. We don't have any other further questions. It's if you guys want, we can just wait for 2 minutes for another question, or
Yeah.
what do you guys think?
No, it's I see the chat here. It's very cool to see that so many people from all over the world has joined in. Thank you all for joining in. It's very cool.
Yeah, I see we just got another question here from.
Yeah. How fast is your support team?
All right, yeah, that's we actually have a really really high quality of support as of now. We have dedicated support lines with all our customers and are often close by. Or we set up offices in the US where our main customer base is, and as well in Germany and our headquarters in Norway. So we generally reply to support tickets within a couple of minutes typically.
Yeah. I think we just got another question. It's fast. Large faculty force were seldom totally flat. Small imperfections, potholes. So what size bumps can be accommodated?
That is a good question. Usually we say bumps up to 5 millimeters are okay, depending on the geometry. I mean, if you have very sharp edges, we would want to repair it because we don't want to destroy the wheels themselves. We usually do a very thorough walkthrough of the plant before we install our wheels with the customers, just to make sure that the environment is okay. And there is a lot that can be done with a little bit of concrete, a little bit of epoxy, just to fix imperfections in the floor. So size of bumps, I would say 5 millimeters is a good rule of thumb, but it basically depends on the geometry of them as well.
Yeah, speaking of bumps, do you do a 3D scan before you install them, or it's a manual like scanning or monitoring if there's a bump on the floor or not?
For now, it's a visual inspection, but one can only imagine what we can bring in the future if we can have a robot that does a little scan of the floors and gives a full report. So maybe in the future.
What would be the safety limits that make the system stay still before what events?
Right. So in general, if the robot is navigating around, it won't really activate any of the safety events. However, what will typically happen if someone walks out in front or jumps out in front of the robot and gets within its safety bounding box, that will trigger a safety event. And that happens if the robot is in transit. It will increase the safety bounds by a proportion depending on how fast it is traveling. And we also have safety events regarding if the emergency stop button is pressed or if some wheel malfunctions or does not perform as expected.
Okay. I believe that's the end of the time. So, okay. So there was another question regarding the webinar that will be available. Of course, it will be available on YouTube. And okay. No other questions, I believe.
Oh, there is one question I see. I can just take that really quickly. It's the earthquake question.
This one is a nice one. Yeah.
We have actually performed shake tests, yes. I guess this also depends on the magnitude of the earthquake, but we should be good for at least an okay one or a moderate one. So, but
do
yes,
they do they stop moving, or they go to a safe place or a safe location in terms of earthquake or something?
So integration with emergency systems is always a question that comes up. Maybe Alex can give some more input.
So earthquakes, I haven't heard. We haven't planned specifically for earthquakes. However, we do integrate with the customer's safety systems, especially the fire system. So if a fire alarm goes off, the robots will kind of evacuate or remove themselves from evacuation areas to make sure that all the operators can get out of the plant safety.
All right. So thank you everyone for joining. Thank you, Casper, Ben, for I forgot your name.
I'm Alex. Yeah.
Alex. Yeah. Sorry, I didn't see the name. Though. Yeah, it was a really nice webinar, and I believe, if I'm not mistaken, there was going to be another Elektor webinar in about next 2 weeks. And thank you, Wilmy, again for joining this webinar with us, and thank you everyone for attending.
Thank
Have
you.
a great
Thank
day,
you very
and
much for having
goodbye.
us.
Thank you
Thank
for
you
having
so
us. Yeah, thank you so much, and thanks for the great questions to everyone in chat. It's been great presenting to you.